All right. Okay, so, all right, so you've got to go back and remember, absolute value, if we have the absolute value of a number equals 3, we have to account for both solutions. We have to account for when x is equal to 3. I don't know why that's there. Okay? So x equals 3, or you can put negative x equal to positive 3, or x equal to negative 3. I like this one version here. This is my favorite version. Okay, so we got to make sure we account for both possibilities. Now, when we do absolute values, okay, absolute values require the same idea. We got to get two answers, but now we've got to think about what goes between them. Okay, for example, if I want my absolute value to be less than 3, I can't just go x is less than 3 and x is less than negative 3. Because x is less than 3 does solve this problem of being less than 3 right here, but x is less than negative 3 sends me this way. And these numbers like negative 4, negative 5, negative 6, the absolute value of those is greater than 3. So I can't do this less than negative 3 thing. I've got to do something else. I've got to turn this around and make this greater than negative 3. Because that's what this has to be, is greater than negative 3. So when I come out of the absolute value with inequalities, I do one exactly the same as I do normally, and I flip one completely around. I have it be greater than, I flip the inequality sign around, and change the sign of my number. Okay? And so the absolute value of 3 is x is less than 3, which is always true. And then I like this one here. We flip it around, and that gives me my true answer right there. Okay? Now, the great thing about inequalities is they only have two choices for graphing. Okay? And problems. Let me see what this says here. So, there's two things. You should write this on here. Greater thans are always or problems. Right there. So if you see a greater than in there, that always means you're going to get an or graph. Every single time. Alright? So greater than, this being greater than, implies that we're going to get that or graph that splits up, where the graphs go apart from each other, okay? And less thans, if I have a less than, these are always going to be and graphs. So these are always or, these are always and. These always go together in the middle. Okay? So we can kind of bank on that being true, that if it's greater than, we're going to get a split graph. We only get two kinds of graphs for inequalities, or absolute values. We get a split graph, or we get the overlap graph in the middle. We don't get anything else. We only get those two. So graphing is not as big a problem as it was with the compounds. Okay? You have to recognize what we're doing. Alright? So we got to make sure we do the same three steps that we did with solving the absolute values. We just got to see what's possible. And there are some things that don't work. For example, let me show you what these are. And these are additions to your notes. You've got to write these somewhere on your notes. Okay? For example, okay, if I say the absolute value of x is greater than negative 5. Now before, we had the negative in there, we said it's not possible. But we've got to think about this because the inequality changed a little bit. Okay, so the absolute value of a number is always positive. So is positive always bigger than negative 5? Yeah. So this is an all real numbers graph. Anytime you're greater than a negative number, this is going to be all solutions. Okay, because every absolute value of every number will be bigger than negative 5. Okay? What about absolute values that are less than negative 5? Can absolute value be less than a negative number? No, it can't be. So therefore, this is no solution. Okay, so you got to watch your inequalities because sometimes you have a negative number that is still possible. All right. Now, what about 0? Is that possible? Can absolute value be greater than or equal to 0? And if it is, what numbers work? Absolute value's got to be a positive number, all positive numbers are bigger than 0, so that works. That's definitely all numbers again. Okay? Alright, what about less than 0? Numbers that are less than 0 are negative. Can absolute values be negative? So this is back to no solution again. Okay? So you gotta watch that inequality. That can tell you a different story just by having negative numbers or zeros there. You gotta pay attention to what's going on there. Okay? And the last thing is, okay, if I have a number outside here that's negative, and I'm dividing by it, okay, remember I gotta isolate that. The minute I divide by a negative number, I've got to make sure that I change my inequality sign around. Multiplying and dividing by a negative number still holds true with the absolute values. Okay? That's still in play. Alright? Okay. Let's go back with our notes then. Number 1, down here at the bottom. Okay? Now, you're going to be doing two things. You're going to be graphing some solutions and writing some solutions. So we're going to look at how to do both. Okay? Alright, so this is less than. What do I expect? What kind of graphs do I get when I get less than? This is an AND graph. And what do AND graphs do? They overlap in the middle, remember? That's going to be an AND graph. It's going to overlap in the middle. Guaranteed it's going to happen with that. Alright? So first question. Is it isolated? Now that means that when I draw my line here, and I check my inequality symbol over here, is that alone over there? On that side of the graph, is there anything else besides the inequality over there? Or the absolute value over there, sorry. So it's isolated, right? Okay, second thing we check, is it possible? Can absolute value be less than 5? Yeah, there are numbers that are less than 5 that will be positive, so that's possible. So possible is good. So the third thing we do is we separate and solve. Okay? So we never solve this. We never solve inside here. We don't solve inside there. We pull it out before we solve it. So I pull the x out, have it be less than 5. There's the first one. When the second one comes out, we change the inequality sign directions, and we change that to -5. Okay, we got to do both changes on that right there. So that's a big one. These have the two changes right here. Got to change this inequality sign and the sign of the number. Okay? And then this is an AND graph. So we know what's going to happen here. Okay? So we put AND between them. And we go over here and we go, okay? We can do our pencil graph, I guess. We'll do that. I got +5. Open circle going left. Got -5. Open circle going right. So there's the overlap, which we expected. Okay? So my final graph will be x is less than 5. So I put an open circle here. I put an open circle at -5. I put my graph between the two. Okay? And then I write my final answer. My final answer is x is less than 5 and x is greater than -5. Okay? So if you're graphing answers, you put it that way. If you're typing answers, you type the whole thing in. Okay? Questions on that? Okay? This is really out of focus, so let's see if we can get a focus here. There we go. Okay. All right. Questions on that? Okay. Let's flip to the next page then. Look at number 2. Okay, now if you notice this, there's no graph over here. That means we're not graphing this one. We're going to write the equation, we're going to write the answer for this one, just because we're not going to graph it. Okay? So they don't give you a graph, you're not graphing, you just write the answer. Alright, so here we go. What's the first step? Get it nice and big here so we can see it on the... Okay? We've got to isolate. So we drop our line in here, and we ask, is this absolute value alone on that side of the equation? No, this is not. There's that negative 17 over there. We got to get that negative 17 off that side before we do anything else. So we're going to add 17 to this side, add 17 to this side. We're going to get absolute value of y is greater than or equal to 6. Okay with that now? Okay, so we're isolated. Is it possible now? Can I have graphs be bigger than 6? Okay? All right? Now, what kind of graphs do I expect? It's greater than, so I expect what kind of graph? This is an OR graph. That means it's going to be split, both sides. Okay? OR graph split on the sides. Greater thans are always OR graphs, always. Okay? So it's going to be a split graph. The y? Yeah, it's the exponent, but no, not an exponent, it's absolute value. Okay? Yeah, exponent's a little number up top. No, it's this right here. This greater than symbol. Greater than here means OR graph on these graphs. Okay? I'll show you why. Okay? Let me show you. Okay? You'll see really quick why it's an OR graph, and I'll show you why. Okay? All right? But when we do this, to get out of this, now we don't solve this. We split this up. So we do step 3 is split and solve. So when I split this up, I pull the y out, and that's greater than or equal to 6. Then I pull the other y out, and it's less than or equal to negative 6. So if we look at the graph on this, we're not going to graph it, we're going to look at it anyway. Okay? If I look at the graph on this one, this is why it's an OR graph. Okay? I've got this circle at positive 6 going up this way, because it's greater than 6, right? And this one over here is negative 6, its open circle going that way. That's why it's an OR graph, because they always split up. The only way to get numbers that are greater, the absolute values are greater than 6, is to have numbers that are greater than 6 positive, and numbers that are less than negative 6, like negative 7, negative 8, negative 9. That's where you get those down there. So anytime you see a greater than, you're going to get an OR graph like this, guaranteed. Okay? That make sense? Anytime you see this symbol right here, greater than. Okay? I don't care what the variable is. When you see that symbol, the answer is going to be greater than graph, like this. We just don't know where the numbers are. We've got to find where the numbers go. Okay? So how do I write this then? Well, this is an OR. So I write my answer, y is greater than or equal to 6, or y is less than or equal to negative 6. That's exactly how I write my answers, like that. Okay? How do I tell what? Less thans or and. Okay? Greater thans are always ORs. Less thans are always ands. That's how the absolute value works. It's the only two graphs you got to worry about. Okay? The split graph is the OR graph. The overlapping graph is the AND graph, and that's all the way it is on these. Okay? There won't be other 4 graphs don't involve on this. Okay? Are we okay with that now? Okay. Alright, so, if we look at number 3 here, what kind of graph am I going to get? This is a less than. What kind of a graph am I going to get? Lily? I'm less than, so what kind of graph do I get? An AND graph, exactly. Okay, so I know right now this is an AND graph. I know automatically what it's going to be. It's going to be the graph that has the overlap in the middle, right? Automatically, I can tell that from the sign. Okay. All right. So isolate. That's the first question. Isolate. Okay, is my absolute value alone over here? Now that's 6 inside, so yes, this is alone. Okay, we're looking at between the two lines. We're looking between these two big lines right here. Is that alone on that side? Yes. That whole thing's alone. Alright? Is it possible? Can I have absolute values less than 2? Yeah, that's possible. Not very many of them, but there's some there. Okay? And so now you got to split it. Here's the fun part. Split and solve. When you split and solve this, remember, we do not solve this. Do not solve this like this. In this format, you do not solve it. You got to split it first. So when you split it, you take an x minus 6 down here and set it less than or equal to 2. There's the first one. And the second one, you take the x minus 6 and make it greater than or equal to negative 2. That's where you do two problems. You don't solve it in the absolute value. You pull it out and then solve. Okay? So you separate and then solve. Now I got to solve both of these. And now because I had a number inside that absolute value that was besides just the x, I'm going to get two different numbers down here. So when I get down here, I'm going to add 6 to both sides. And I'm going to get x is less than or equal to positive 8. And I'm going to solve this, and I'm going to add 6 to both sides. I'm going to get x is greater than or equal to positive 4. Okay, and I know this is an and graph, so I'm going to put an and right between them. Because it's greater than. Okay? Alright, now if we want to look at the preliminary graph, we can do that. I'm going to have a number of 4, closed circle going up. Going to have an 8 up here, a closed circle going down. My graph overlaps like I knew it was going to. Okay, that's why the AND graph does that. And so when I get to my final answer over here on my graph, I'm going to have a closed circle at 4, a closed circle at 8, and I'm going to go overlap on this, right? So this is my overlap graph. And then my answer, I write x is less than or equal to 8, and x is greater than or equal to 4. And it doesn't matter which one you put first. You're going to put the 4 first, the 8 second, I don't care. Okay? Everybody got that? Okay. All right. Questions on that one? Okay, let's try this next one. This is also a graphing one. So let's get it up here and look. Okay, this is going to be an AND graph or an OR graph. What does that tell me? Greater thans are always OR. Okay? Alright, this is going to be a split graph. We're going to have one go this way, one go this way. It's going to be a split graph. Okay? Draw my line. Am I isolated? Is this alone? Yes. Is it possible? Can I have absolute values bigger than 24? Yes. Okay? So then we split and solve. Okay? So pull the 4x minus 8 out. Is greater than or equal to 24. There's the first one. Okay? Second one, pull the 4x minus 8 out and make it less than or equal to negative 24. Change both those signs. Okay? Here's where my change comes in at. Okay? Okay, solve them. Add 8. Add 8. Get 4x is bigger than or equal to 32. Divide by 4. Got x is bigger than or equal to 8. Solve this one. Going to add 8 to both sides. I get 4x is less than or equal to negative 16. Divide both sides by 4. I get x is less than or equal to negative 4. Okay? The preliminary graph will tell us our story. We know what it is already. I'm going to have a positive 8 up here going bigger. I'm going to have a negative 4 down here going smaller. These are both closed circles, by the way. Going smaller. Which is what I expect with an OR graph. Okay, separation. So my final answer on the graph will be a closed circle at negative 4. Oh, I got the wrong, yeah. Closed circle at negative 4. Graph to the left. Closed circle at positive 8. Graph to the right. And my answer will be x is greater than or equal to 8, or x is less than or equal to 4. Okay? Can't see the graph there. All right? Piece of cake? Okay. So you got to remember, and you guys kind of forgot in the last test, is that absolute value, you got to split it. You can't solve it in the absolute value. You got to pull it out in two different spots. Okay, so you give you two numbers. Okay? All right, last one, then I'm going to turn you loose. Okay? A little bit more complicated. We're not graphing this, we're just going to write the answer here. So, okay? Hold on your decision on this, see what kind of graph it is until after you get it isolated, because this might change. Okay? So isolate first. It's got a lot of junk around over here. What's got to get rid of first? Yeah, that -3. How do I get rid of that? Add 3 to both sides. Okay? Then I have 7 absolute u minus 5 is less than 21. And really I said hold off, because if you divide right now by a negative number, it's going to flip that sign around. So wait until you decide what kind of graph it is until you get it isolated. So now divide both sides by positive 7. That does not change. I get absolute u minus 5 is less than 3. Okay? Now this is going to be what kind of graph? That's going to be an AND graph. Guaranteed, okay? So to solve this, pull it apart. Got an a minus 5 is less than 3. Got an a minus 5 is greater than -3. There's my change over there. Okay, and then solve it. If I add 5 to both sides, I'm going to get a is less than 8. If I add 5 to both sides here, I get a is greater than 2. And I know that's an AND graph, because it's supposed to be, okay? It says less than. So my final answer is a is less than 8, and a is greater than 2. That's how I type in my answer. Okay? Now, if you're feeling real adventurous, you can put your answer like this. Means the same thing. But if you don't feel like doing that, just do it at the end and you're fine. This is when you get old and brave like me, you can do this. But don't worry about doing that. Do this one. Okay? Okay, questions? All right, what are you waiting for? Get going. Okay? 10:06. You got about 23 minutes. Where? Yeah. Sign in. You okay? Okay. Okay, remember, we're on short day, so we got like 23 minutes for a class to okay? Okay. Oh, shoot.